Now we'll work an example where we construct a confidence interval estimate for the mean when the population standard deviation sigma is unknown. So a simple random sample of 150 students is drawn from a population of 3,000 college students. Among the sampled students, the average IQ score is 115, with a standard deviation of 10. Construct a 99% confidence interval estimate of the population mean IQ score for the college students. Well, now, if this were just a problem where we were constructing a confidence interval estimate of the mean, and we didn't know whether or not it was the situation where sigma was known or not known, we had to get that from the problem statement, then this is where, as I mentioned before, you need to pay close attention to how they give you that standard deviation. Notice they don't have the symbol there for sigma or S, so you have to get it from the language. And it's in the same sentence. When they talk about standard deviation, that's in the same sentence of talking about the sample. So when they say the average IQ score is 115, that's X bar, or the sample mean. And it continues in that same sentence with a standard deviation of 10. So I can tell that they're giving me the sample standard deviation and not the population standard deviation. So that's one thing you'll have to be able to do eventually, is when these problems are all together, is to be able to sort out which it is. And that's how, one way you can find the difference or determine the difference between population and sample, is by looking at where are they giving you that information. What else is in that sentence? Okay, so let's see what we are given here. We know we have a sample size of 150. They also give us the population size of 3,000, but that won't enter into our calculations. It's just some given information. That's fine. Okay, they give us the sample mean, 115, and as we just discussed, they give us the sample standard deviation of 10. Now the confidence level is 99%, so that leads us to an alpha of 0.01, and therefore an alpha over 2 of 0.01 over 2, or 0.005. And so we have determined that sigma is unknown, so that leads us to the t-path, and in the t-path it says, well, is the population normally distributed? Well, IQ scores do tend to be normally distributed, however, they didn't say anything about that here, but our sample size is very large, much larger than 30, so we really aren't concerned with the distribution of the population. And it was a simple random sample. Notice that. And one of our requirements. So I'm going to show you two methods for solving this and coming up with that confidence interval estimate. And the first one, we'll use our formula for the margin of error. And so let's see, let me label these. This will be method 1. Okay, and in method 1, we'll use the calculation for the margin of error, where we use the critical value times sample standard deviation over the square root of n. So our critical value, t alpha over 2, is going to be t.005, and remember we need the degrees of freedom. So let's come up here. Degrees of freedom, that's n minus 1, 150 minus 1, or 149. So 149. Okay, we'll get that from the inverse t function. So go to our distributions, inverse t. Area this time is 1 minus 0.005. Degrees of freedom is 149. Enter. Okay, that looks good. That's what I want. Enter. 2.609, or 2.61 we'll use. Okay. And now to construct our confidence interval estimate, all I need is to take my sample standard deviation minus the margin of error, and my parameter will lie between that number and sample standard deviation plus the margin of error. So 115 minus So let's compute that margin of error. E equals 2.61 times sample standard deviation over the square root of the sample size. And we get 2.131, I'm just going to carry that out, 06. Okay? So now, using this construction for my confidence interval estimate, I have 115 minus 2.13106 and 115 plus 2.13106. And we remember the rounding rule here. We did not have the raw data. I don't have those 150 IQ scores. All I have are the statistics, so I will round to the same as my sample mean. That means no decimal places, right? So I carried this out quite further than I needed to, but let's just see what we have here. 112.86894. Kind of overdid that on my accuracy. But now rounding to no decimal places, 113 and 117. Okay, so that's the method where you actually calculate the margin of error. I also want to show you a method using the technology that's available with your TI-8384 calculator. I'll leave that there. Okay. Okay, so we will use stat, tests, t interval. Okay, stat, tests, tab down to t interval. And now it's blinking on data, but I also can select stats. If I had the raw data in a list in my calculator, then I would highlight data, but I don't. All I have are the statistics. I have the sample mean and the sample standard deviation. So stats, I'll enter that, and notice that the list went away. There was a place for a list when I had data, but I don't have a list of data, so that went away. Mean, our mean was 115. Our sample standard deviation was 10. Our sample size was 150. Our confidence level was 99%. And we'll calculate. Okay, so we get 112.87, 117.13. And now writing it in this format and rounding, following the rounding rule where we round to the same number of decimal places as our sample mean. And we get the same results. Now, it doesn't matter which method you use, you still need to write your interpretation. So, we are 99% confident that the true population mean IQ score for the students is between 113 and 117.